morning, everyone. So today I'm so honored to introduce one of our project we conduct from last year in Đông Á University with my thank you and acknowledge for the unlimited support from the Dr. Minh Pianda and President Lương Minh Sắc and on the flexibility from the university. With the ideas how we get, as you know, we talk about the climate change and how to the theory and how to how to make the solution to turn the idea to become the real. So when we start with the idea for this products, we think a lot about how we can preserve, how we can protect the traditional resources. And luckily, when I work in the matter of the civil engineering, with my knowledge and the team, the student team from the Faculty of Civil Engineering, we did the project with the name the fiber. We use the fiber materials to innovate the fiber reinforced concrete structural intercrete. And this, how about the detail? I will show you in next. So this is my biography. If you have any question on this project, you can contact me with this email. So this is the main content. I will show you, because the time is limited, so I will go through with some unnecessary content. So first, I will give you the overview about our project. The second, I will talk about the material and method. And the third part, I will show you some research highlights. And the last one, I will give you some conclusion. So, nowadays, the using of the traditional material for construction material is now in limits, and maybe it's not allowed by the government. And many, I think the best thing like stock waste or organic waste in society, and the way to recycle them become a national challenge. Yeah. And come along with desire to reduce the natural traditional material in construction demands. We find that the old construction material investigated in my research, will be replaced by the organic one. And stand on that idea, we use the fiber materials, includes the coconut fibers and honeycomb carbon slab. Yeah, you can easily to find coconut fiber because we have the long scope and many coconut trees here. I think it's like the already material. And the honeycomb carbon slab, you can use electric stove, but in the past, there's still some poor resident, they still use the honeycomb carbon slab. Yeah. So this is we had already material and we had easy to use to put in the cement aggregate and we can make the concrete. Yeah, that's the good idea, and I think it's possible, and that makes us to do this project. And and this research or these studies provide understanding, give you the understanding about how we replace the traditional material, to make the concrete product. And because in the research, the study of engineering, so it requires some engineering methods. And these methods, we want to, the key parameter, the method to determine the key parameter here, we use the non-destructive and destructive research. I will show you later. And this is the project we did last year, and until now we still modifying and updating and everything, and we can open more wide orientation in the future. So that's it, the overview. The organic waste, the civil waste now become they push and always they put into the environment more and more, and it's become the really serious. So from the Ministry of Environment and Resources, they estimate 2.5 million tons of waste per year. Also, for the climate change, Like you know, like when to make the cement, make concrete, you use the river sand. And when you employ or digging too much or too deep to the sea's bottom, it will cause the bank erosion here. So it's not good. Yeah. And so now become this kind of the phenomena happen day by day, year by year. And nowadays in some province in the south of Vietnam, many houses or many construction close to the river, like the river bank, they collapse and sunk and fall down to the river. It's so dangerous because the core reason comes from you exploit the many sand here, river sand. This means that you can see that how they dig, how they exploit the river sand. Yeah. But now the Vietnamese government they ban or they not allowed to do this one. So because so that this is this is one like traditional material, but now they ban. So we have to find the way or find out our way to use the replaced material. And for the research area for this study, we first apply in the central Vietnam or in particular in the Da Nang city. And if the project will become, small like a small priority or become more, important, we have a plan to to expand the research area to the central, in many provinces in central Vietnam. So, this is the link to our research. For the research targets or the purpose, we would like to determine the suitable mixed ratio of coconut fiber and honeycomb carbon slag for concrete aggregates. And follow the Vietnamese engineering standards, we make the concrete mark 150. Yeah. This means every centimeter can bear 150 kilogram. Yeah. And the current day or experiment time, we did it in about 90 days, around 3 months. Yeah. And then every like the experiment sample, we will measure or we will determine the strength, the concrete strength. Yeah, but the methods, non-destructive and destructive methods. And then we make the linear relationship among study concrete strength to other parameters. The objective, of course, the objective is the concrete strength. But we would like to know about the value of this one. This is so important. Yeah, and this is our team, the Đông Á University, the student from the Faculty of Civil Engineering. We developed this, we conduct this project from last year, and we had some like we had some mark in our research. Yeah, and we also bring like the prototype of the concrete, like concrete block. Yeah, into many contests. And also we, in that time, in the near future, we will bring this to to check the quality, and finally we want to get the certificate, quality certificate from the Department of the Construction. Yeah. And this is some activity that the students they collect. You know, this one is the slab. The honeycomb silicon slab, this one. That we can, where we get it? We get it from the resident. We go to every house in this district and we collect this kind of material. And I mentioned again, like every activity we did in the Đông Á University laboratory for the construction. So I will give you some like idea, or I have something about coconut fiber. Yeah, like you know, this is one. The coconut fiber is come from the coconuts. Yeah, coconuts. So it can improve the durability of concrete. It means that they can enhance the concrete age. the concrete durability, the long-term serving. Yeah. And also, it can reduce the cracking. You know, when the concrete block under construction, they had to bear, many or heavy weights or many loads. So easy to get cracked. But when you put some coconut fiber in the concrete aggregates, so it can reduce that. Yeah. And also the fiber can create more cohesive speed. It's like the sticky. It can connect and it will improve the skeleton of the concrete. And they can have control cracking that occur during the drying and the wet day. Also, yeah, of course, coconut, how you can see it here, it look light. It's not so heavy. So now the second function is coconut fiber is incorporating into concrete. And how to say it look like the lighter composite material. I think it's good because you can apply this for like some modern structure, or we can make the lightweight concrete. It's the new material for construction. And the next one, the coconut fiber can improve the flexible strength, flexible like tensile capability. And the next one is had the subtability. It look like coconut fiber easy to find as a natural engineering, a natural material and renewable resource. And what we want to mention, what we want to focus here, this is the eco-friendly material. That is the most important, like the green material. It can adapt to the climate change behavior. Also, when you use this coconut fiber, it looks like a thermal isolation. It's how to say, it can like a natural insulating property. Okay. So it has like a thermal isolation. That is coconut fiber. And this is the property of this material. You can take a look. And the second fiber material is the honeycomb charcoal slag. That's it. We did it. Our Đông Á University student has conducted by themselves to collect in the civil area. Also the charcoal slag also enhance durability, reduce the heat and hydration, improve the workability, increase the strength and sustainability. And so, two fiber materials, they adapt to the criteria for safety, green, and sustainable. And we had it here. You can see that we did the concrete block, which followed with the ratio for the aggregates. You can see here. And this is the ratio. We're going to put the charcoal slag and coconut fiber into the aggregate, into the concrete block. You see here. So, and then we use the ultrasonic pull velocity and rebound hammer into non-destructive methods to determine the concrete strength. And how they look, we will see here. This is the process, how we did it. We collect, what we did here is follow the ancient Vietnamese engineering standard for concrete. You can see here, this is the machine we do it. Ultrasonic, we use the ultrasonic waves to determine the concrete strength. And this is the rebound hammer. The second non-destructive method is conducted by Đông Á University's student in the laboratory. And also, finally, we discover this. To discover a very important thing here, we had the result for the variation of the concrete strength until the 90 days. And you see, after 28 days, the concrete strength and they stay inside the red line, the red zone here. It means the red zone is mean the Vietnamese engineering standard. What does mean? That means our results is reliable and adapt to the Vietnamese engineering standard. Yeah, so that means our research is possible and reliable. And until and stand on these results, yeah, we have some conclusion here, like the using of coconut fiber and charcoal slag aggregates is possible. Yeah, you can possible to replace the traditional material, and we can make the concrete stand up to 150 and 200 kilograms per centimeter square. Yeah, that's like the multiple application for different concrete structure. Yeah, and the next one, the concrete comprehensive strength. Yeah. They had like significant, they just only had significant rise in the first 3 days and up to 28 days. And then they keep constant. It means they reach to the ultimate strength after 28 days. That sounds good. That is, it means it's possible and also adapt to the Vietnamese engineering standard. Yeah. And next one, and for the future, this result is very important for the future. In the future, we have the plan to apply the AI and deep learning to determine or simulate the concrete structure, like the action in the real time. We will put some like realistic idea to put, and we simulate the action of the action and the work of the concrete structure that they can buy the coconut fiber and charcoal slag with it. And this will like our next orientation research. And also this finished my presentation for the new material that adapt to the climate change now today. Thank you so much for your listening.